Hi there, welcome back to our channel. And if you remember, in a previous video, we talked about the H parameter model of the bipolar junction transistor. And this time, we are going to talk about the hybrid pi model of the transistor. So, as you can see on your screen, I have this equivalent circuit or a model representing the bipolar junction transistor. So how do I know this? This is a base terminal, this is an emitter terminal, this is a collector terminal, and I am saying the emitter is a common with respect to base and the collector. So this typical model is applicable for common emitter configuration of a BJT. However, if you would like to make base as a common terminal or collector as a common terminal, we have seen in our previous models in the video how to configure that kind of equivalent circuit for other two possible combination, that is common base and common collector. So right now we focus here on this equivalent circuit, which is a hybrid pi model of a BJT in common emitter mode. So what you see here, the VBE, all small letters, and your output voltage across the resistance here is your VCE. These are the two input and output voltage respectively. Then the input current that is coming from this node is the IB or I1, which is your base current, and the output current which is coming from the collector into the circuit is I2, which is collector current IC. So now we will define few terms with respect to this model. So whenever you will have a BJT and a circuit associated with the BJT, the first task of a designer is to draw its equivalent model just like as shown in this figure. This helps the designer to analyze the circuit behavior, especially when deriving an AC response or frequency response of the transistor circuits. Okay, so we see now your base and emitter is the input side and the voltage is VBE, and your collector and emitter is an output side. Okay, so first parameter that we would like to define is the transconductance, which is indicated by GM, and transconductance is a ratio of output current divided by input voltage. So output current in this BJT circuit is your collector current, and the input voltage is your base to emitter junction voltage. With VCE is equal to 0, it means you see that the collector and emitter terminals are kept open circuited. Sorry, the short circuited, because VC is 0 here. And we see that uh, it is equal to IC over VT. Okay, where IC is the DC bias current or quiescent collector current or collector bias current, and Vt is called as thermal voltage. Vt is given as the ratio as Kt over E, where K is the Boltzmann constant, T is the temperature, and E is an electron charge. So Vt is the thermal voltage. At room temperature, if you analyze this circuit, its value is 25 millivolts. So you just plug in the value of your Vt in this expression. After biasing the BJT, you plug in the value of the collector bias current or a DC value of the collector current, you get your transconductance for the BJT circuit, because transconductance then helps you to evaluate and calculate the voltage gain. Or, for example, you have the transconductance output, you can use this expression to calculate that. Okay, now next you see this small letter r pi in subscript, that is an input resistance. So resistance is a ratio of voltage over the current, and since it is an input resistance, it is the ratio of input voltage VBE divided by input current IB by keeping VCE is equal to 0. So it is an keeping the output circuit open circuit, and it is given as Vt over Ib. Again, Vt is your thermal voltage. For room temperature analysis, keep it the value of 25 volt. Ib is your bias current, DC bias current for the base terminal. So have that value, and it can also be given as the ratio of beta divided by Gm. So if you know the value of Gm, beta is the DC current gain, which can be obtained by referring to the data sheet provided by the manufacturer for that particular transistor, and you get the value of R pi. Now, finally, you have, and here is that R pi. So it is the resistance in the input circuit. Now you have the output resistance, which is connected between collector and the emitter. Remember, the input resistance is connected between base and emitter. So RO is the output resistance, which is the ratio of output voltage divided by output current. Output voltage is VCE, in output current is IC. Since it is small letters, all the quantities are expressed in small letters. This is referring to the AC analysis. We are referring to the AC circuit and AC model of the BJT. And this is by keeping VBE is equal to 0. This time your base to emitter junction is kept open circuited. And finally, this value of the RO can be given as 1 over IC in bracket VA, which is VA refers to the early voltage. So that is the term coming from the device physics. We're not going to explore that right now. So VA plus VCE, this is the DC voltage across the collector and the emitter. Approximately, the resistance RO can be evaluated as early voltage divided by the DC collector current. Okay, so this is how you can get the model, hybrid pi model for a BJT. You simply draw the terminals, have the input resistance, have the output resistance, and this is a dependent source actually, which has a value of Gm into VBE. So this arrow indicates it's a collector current, and IC collector current is equal to Gm over VBE, and hence Gm would be the ratio of IC over VBE. Okay, so when this current IC flows through the output resistance, you have an output voltage, which is which can be IC is Gm into VBE times RO. That will be your output voltage. And then you can calculate the voltage gain and the current gain and so many other parameters. So hope you understood the basics of hybrid pi model, how to derive it, and different quantities associated with respect to it. An exercise for you would be derive a model, hybrid pi model for common base configuration and the common collector configurations, and give the expressions, write the expressions for them.